Hi, I'm Mr. McHugh. This is a Regents Prep special lesson on rationalizing denominators. To go along with this lesson, I have a special handout that you can access on this website. So at the bottom of the blog entry, you can click on the attachment for rationalizing denominators, and you can follow along with me. So if you haven't already accessed that attachment, go ahead and do that right now so you can follow along as I work through some problems. So what I'm about to do is simplify a fraction that has a radical in the denominator. Now we've already seen this before when it's just a number like radical 5 in the denominator. The difference here is that it's got this 5 that it's adding with, okay? So what we have to do is multiply it by a special fraction. Instead of just multiplying it by radical 5 over radical 5, we have to multiply it by something called a conjugate. So let me show you what that looks like. So we're going to multiply it by another fraction, only this time it's going to be 5 minus radical 5 on the bottom and on the top. Alright, and this is called a conjugate. It's an important vocabulary term for the Regents exam as well. They've actually had questions where they'll just say, what is the conjugate of 5 plus radical 5? The answer would be 5 minus radical 5. The way to find a conjugate is you just change the sign of whichever sign is before the radical. So if this was 5 minus radical 5, it would have been 5 plus radical 5. So it doesn't matter what the sign is of this number. All that matters is the sign before the radical. That's all that's important. Alright, so now we want to look at evaluating. How do we make sense of this expression? Well, the top part's not too bad. You can treat each part of the conjugate like it's a bubble. Okay? So when you multiply 3 times 5 minus radical 5, it's basically distribution. So you'll have to do 3 times 5 minus radical 5, and you'll distribute that 3 onto both terms. Now the bottom is a little trickier, because what you have is 5 plus radical 5, and then you're multiplying it by 5 minus radical 5. Okay? So whenever you have two binomials like this, you have to FOIL. So foiling is the method that you'll have to use. You FOIL the bottom and you distribute the top. Alright? So you distribute the top, you'll FOIL the bottom. So this is what it's going to look like. 3 times 5 is 15. You keep that negative sign there. And then 3 times radical 5 is just 3 radical 5. Now this is when it gets a little more tricky when you have to FOIL. 5 times 5, that's 25. 5 times negative radical 5 becomes minus 5 radical 5. Alright, so we've distributed the 5 onto the two terms here. Now we have to distribute the radical 5. So radical 5 times 5 is plus positive 5 radical 5. And then the last part, this is the trickiest but the most important, radical 5 times negative radical 5. Well, a radical times a radical, any radical times itself is just the number inside. So radical 5 times radical 5 is just equal to 5. However, since it's a plus, a positive times a negative, the answer is going to be negative. So again, positive radical 5 times negative radical 5 is going to equal negative 5. So you write a minus 5 at the end. I know that's a long, nasty looking fraction, but it gets a lot better. So if you notice, when you try to combine like terms, negative 5 rad 5 and positive 5 rad 5, well, these two are going to cancel out. Because a negative and a positive together will cancel out. So you're left with 25 minus 5. This is your other set of like terms. Alright? And 25 minus 5 is 20. So you end up with, as your final answer, you still have your 15 minus 3 radical 5 on the top. And now you have 20 on the bottom. And that's really as far as you can go. If you wanted to, you could factor a 3 out of the top, but it wouldn't really help you simplify because 3 doesn't go into 20. Alright, so that is as far as you can go with this fraction. And now you have successfully rationalized the denominator. Again, because there's no square root in the denominator. That's the whole point, because they cancel out in that step there. I'm going to go through problem number 2 just for one extra practice problem, and then I want you to try to do this on your own. You can always check your answers on the last page of the handout. Alright, so the second problem is 4 over 2 minus the square root of 3. So again, we're going to have to multiply this by its conjugate. So we always multiply by whatever opposite sign is. So this is 2 minus radical 3. We'll multiply by 2 plus radical 3. We'll do that on the top and the bottom. Okay? So again, we have to just treat all of these like they're in bubbles, and we have to distribute across the top. So 4 times 2, that's 8. 4 times radical 3 is plus 4 radical 3. Alright? That's the easy part. Now the bottom is the hard part. We have to FOIL. 2 times 2, that's 4. 2 times positive radical 3, that'll be plus 2 radical 3. The negative radical 3 times 2 becomes minus 2 radical 3. Okay? And then the hard part again, negative radical 3 times positive radical 3, that'll be minus 3. Alright? Because the radical times the radical becomes just 3. I mean, you will notice a pattern that this last step is always going to be a minus sign. And you'll also know that these two middle terms will cancel out. So if you get adept enough at this, really all you have to multiply is the first and the last. The outer and the inner are going to cancel each other out. So when you're foiling, you really just need to do 2 times 2, negative radical 3 times positive radical 3. Alright, let's simplify this just a little bit more. This actually turns out to be very nice, because when you simplify it, you still have 8 plus 4 radical 3 on top. And then on the bottom, 4 minus 3, that just equals 1. And as you know, anything divided by 1 is just itself. So your final answer is just 8 plus 4 radical 3. And you're done. So now I want you to try practicing the rest of the problems on this handout on your own. Check your answers on the last page of the handout. And then the second page of this handout is very similar to this, only it deals with imaginary numbers. Check out my video on imaginary numbers for some guidance on how to solve those. Thank you for watching, and good luck.